Okay. So, welcome everyone. So, what we want to do is to try to understand the process of creating a modular smart contract that is using the Diamond standard. Yeah. Can I what? Yeah. Okay. Yes, I have it. No. Let me check. So, this one. Mm. So you can just remind me to be checking it at intervals so that it doesn't stop. Mm. Okay. So what we want to do now is we want to try to we are going to try to understand the process, and we are going to convert a smart contract to diamond while explaining everything. So I have sent the template that we are going to make use of. So we are going to be using this Foundry Adapt template, one that was developed by Tim Dan. So I actually made an update. So I added just a little script to it to do something. So this is what we are going to be making use of in order to build our diamond. So what we are going to do now is just to clone this repo. Am I sharing my screen already? Okay, okay, I started. Um, now, now, please, if anyone has any question, you can just ask at any point so that I want to make sure that as we are moving from one state to another, that we all understand what we are doing, like we are all on the same page, so that there's going to be minimal back and forth. So now I have cloned the repo to this diamond contract tutorial. So I'm going to go into it now. Okay. Now, so everyone understands at this point, at this stage, the need for diamond contracts. So there actually are many reasons for it. So the number how about now? Okay. So we all know that there is a limit to the size of the byte code that you can deploy to a smart contract, which is basically 24 kilobytes. So anything beyond 24 kilobytes will not be able to do that. So there are now different things, different ways that people are thinking about how can you be able to like pass through this. Now, apart from that, another thing is that we know that whenever you deploy a smart contract, we know that whenever you deploy a smart contract, it is immutable. That is, you cannot edit it, you cannot change it. Which means that if there is error in whatever you've deployed, the error is going to stay there forever. So Diamond contract actually provides solution to these two amongst others. So in Diamond contract, what it does is that it is one of what we call the proxy contract. So what's the meaning of a proxy contract? When you put out some proxy contract. So what's the meaning of a proxy contract? When you put out something is acting in proxy, it means that you have something as a face value, then you have another thing that is what acting in its place. Do you get? So when you have something else that is acting in the place of another thing, you say that that thing is a proxy. So when we now have the diamond, the way it works is that we have the diamond, and the diamond it has lots of facets. So a diamond can have as many facets as possible, right? Now, for you to consider something to be a diamond contract, it needs to have three facets. It needs to have three facets. So we have the diamond loop facet, the ownership facet, and the diamond cut. So this contract, the way it is currently now, we are going to first try to understand it before we start adding some things to it. Now, if we should look at this contract now, so here we have inside this contract, we have the diamond.so, we have the facets, we have the interfaces, we have libraries, and we have upgrade initializer. Then we have lib here. Inside lib, that's where we have Pod Studio. We still come back to that. Then we have scripts and test. So these two are normal things. Now let us come to the contract. In the contract, we have the diamond. Now, the diamond is just like if you look at the diamond, it has a constructor. And in the constructor, it takes in the contract owner, the address of the contract owner, and the address of the diamond cut. Now, what do we need these two for? When you are initializing a diamond, so you need to, set the owner of the, because we know that a diamond, of course, it doesn't have any internal function. In a regular smart contract, we want to, in the constructor, we usually set at constructor time, we are going to set the owner to be the message sender, right? So in this case now, what we are doing is we are passing the owner, we are passing it as an argument, and the diamond cut facet. So the owner is going to be used to make sure that whenever we want to perform some upgrade, whenever we want to upgrade, it is only the owner that will be able to do so based on what we've written here. So we are going to be looking at some things here. Now, this diamond cut facet, right? It means that, of course, before you can have its address, it means that you've deployed it before you are deploying your diamond. So we need to take this at the back of our mind, which means that when you want to deploy a diamond contract, the first thing that you are going to deploy is the diamond cut facet. So after you've deployed the diamond cut facet and you have the address with you, you can use that address. You're going to be using it as an argument here, which is that that address will be used for performing upgrade to the diamond. Do we get? So if you should look at this place now, so it's going to take this one here is going to set the contract owner. Now you see here that it is not, we don't have any storage, we don't have any storage here, but here we have the lib diamond dot set contract owner. We are setting the contract owner to be contract owner, the address that we've passed down here. And we now have add the diamond cut, add the diamond cut. So it's an external function from the diamond cut preset. So this one is going to add the diamond cut into the facet. Now in this place now, so there is something that is happening. There's something that is happening here now. So you see that we have the I diamond cut dot facet cut. You know, it's going to perform the diamond cut. It's going to add it in the diamond cut. When it adds it, it means that then we can use that to perform whatever upgrade that we want to do. Now, in our diamond contract, after this constructor, then we have the fallback. Now, in this fallback, that's where we have what's it called? In this fallback, that's where we have this diamond storage. We have a particular diamond storage there that, you know, we have different in the diamond loop. In the diamond loop, that's like our magnifying glass that helps us to check, you know, function selector, the mapping of address and the mapping of function signature to address. So which means that whenever it's going to check for the, it's going to take in the address and it's going to use that one to know the facet that is going to call. So and it's going to make a delegate call to that facet, and of course it's going to take the return. So let's look at the different facets that we have. So in this place now we have three facets here. So let's look at the first one, which is the diamond loop facet. So in the diamond loop facet, this one, what it does is just helping us to map function signature to facet address. So it keeps track of all the facets that we are, of all the function signatures that we have in that particular diamond, which means that when you call a particular function, of course, the function is not in the diamond contract. So since it's not in the diamond contract, then it means that the fallback function will be triggered. And when the fallback function is triggered, the fallback function is going to search our diamond loop facet for that particular function selector. When it sees it, it's going to map it to an address, to a facet address. And that facet address, a delegate call would be made from our diamond contract to that facet address in order to, you know, execute that particular function. So that's basically what our loop facet is doing. Then we have the diamond ownership facet. So what this one is doing, so you can see that we have just two functions in this place. We have owner. So this one, it sets, we use this one to see the owner of a contract, and we use this one to transfer ownership. So if we want to transfer owner from one place to another, we are going to make use of this one. So that's the work of this ownership facet. Then we have the diamond loop facet. Then we have the diamond cut. So this diamond cut now, you'd see that it has what's it called? In the diamond cut, it takes in three parameters. So we have the diamond cut, which is basically, you know, the list of those facets that you want to add. So there's a way in which our diamond cut is made. So the diamond cut, it will have the address of the facet, the type of cut that it is, you know, and then the the other one. Then we have the address init. So in this init, the init function is what is called before the diamond cut, before the facet is added. So let us say that if the facet that you want to add, if it has a constructor, so you would need to, the init will be called before the um, before that particular facet will be added to your diamond. And what init does is it initializes your state variable of that diamond contract. When you have the init before a facet cut, it's going to initialize the facet the what's it called? The state variable of that um facet. So in this place now, we now see that we have something here. Enforce is contract owner, which means that it's only the owner of the contract, something like only owner can do it. And when it does this, we have diamond cut. So then in this place, we now have the libraries, we have the lib diamond. Now in this inside this lib diamond, we have some things there. Number one, we have all these error messages. All these ones, they are error definitions. Then here, we know that in the library, we can store a constant that is an immutable constant inside our library, and we are going to be making use of that fact. So we are storing in this place now, we are storing an immutable constant inside our library. Now if we should look at this immutable constant that we stored there, we actually can also access it in this diamond here. You see that this immutable constant that we stored in this place, which is our diamond storage position, so we are also making use of it in this place. So if you should look at this, the position is diamond storage position. So which means we can use it. That's what we are basically making use of, because we have this lib diamond there. It is making use of the diamond storage pattern. We are still going to talk about it. It's making use of the diamond storage pattern. So the position that it's making use of, whatever position that it is there, I can change this diamond or standard or whatever that we have here. I can change it and it's not going to affect anything, because whatever is there will still be what will still be looked for in this place. And in this place now, we are using this assembly to set the storage, right? Then we now have the facet. So this one is used to get facet from function selector. So it's going to use this to know the function selector of whatever is calling, or what's it called. Then so yeah, we have facet address. And okay, so these ones are structs which are used for state variable actually. So this diamond storage initializer, we are not talking about that yet. So this is another event, search contract owner. So contract owner, you can use this one to get the owner of the contract. So this one is enforce is contract owner. All these ones are functions that we make use of in the. So if you should now look at this one now, we have the diamond cut, right? So we have diamond cuts, the init. So this one, it can perform three functions. So it can add, you see, if you want to add functions, if you want to replace function, if you want to remove function. So each of them, they have what they do. So this is the add function, this is the replace, and this is the remove function, what each of them is doing. So we have all of these functionalities inside our diamond contract. Now we are not going to how am I going to call it? So for this lib diamond, the way it is, we are not touching it. At least for now, we are not touching it. This facet, diamond cost facet, diamond loop facet, ownership facet, we are not touching it also. Then we have this interface that we have here also. We are not touching it yet as well. So what are we now going to do? We want to convert we want to convert a contract. So we are going to be making use of this my what's it called? This is my option contract. So we are going to be making use of this my blind NFT auction contract. So now there's some. So the reason I want to make use of this is because there actually are a lot of things going on inside that if you are able to like you know understand the principles of converting this particular one, at least for most of the contracts that we are writing now, it should be easier for us to like convert them to diamond standard. So that's what we are going to do. So now, if you now look at these interfaces, you see that we have each of the facets, each of the facets that we have, we can create an interface for them so that when we want to interact with our diamond contract, we are going to be making use of that interface and using the address of our diamond contract. So at this point, do we have any question before we move to the need for storage? Do we have any question? Okay. So what's the question that we have? So what's the question? Oh, uh, I'm sorry about that. Okay, the address we pass in at construction of the diamond face of Imogon, is it a random area address or what? No. The address that we pass in at the construction of the diamond facet, there's no diamond facet. So diamond contract itself, when we are deploying the diamond contract itself, the address that we pass in, the first one that we pass in is our own our own address. That is our own address. That address will be set as the owner, which means that if you should pass in just any random address, so that random address that you pass in will be the only address that will be able to upgrade the diamond. So which means if you should pass any wrong address there, it is only owner that will be able to like interact with the diamond courts. I hope that is clear. Exactly. Exactly. Okay. So now, so the first thing that I'm going to do for this one now is to, so I'm going to be installing, my diamond contracts and try to, so before we move on, before we even go to that, let's talk about library also. Let's talk about library. Now, library, the initial thing that we know about library is that libraries are a collection of pure functions, right? So and when we talk about pure functions means functions that don't change state. Functions that don't change state. So that's the initial thing that we know about library. That's where we are going to be starting from. So which means that when we are talking about library, we are thinking of something like the math. We can have the libmath, libsafe math, for example, from OpenZeppelin. So we can have something like, let me um okay, we can have something like a library that How am I going to say it? If we have a library, it is pure in the sense that it doesn't change state. And whatever you want to do, you are the one that is passing it down. Whatever you want to do in the library, you are the one that is passing it down. A library cannot hold state variable. That's another thing that we also know. So which means that it has pure functions. It has pure functions. Now, the next thing that we now want to know is that a library can actually store an immutable state variable which are constants. Do we get? So the first thing that we learned was that libraries, they don't have state variable. They are a collection of pure functions, which means that when you are in a library, you are the one that is passing in the argument. It will just return whatever the return value. It should just return it to you. So now we are now saying that what for libraries, it is possible for a library to own what is an immutable state variable, and that's what we are seeing here. First is hash it is going to return an hexadecimal this thing for you. So we are storing it as diamond storage position. So it is now we are storing it inside the library. So that's another thing that we need to what we need to note. So the next thing is that we actually can store, we can have error messages defined in the library. Now, libraries, they cannot implement these error messages even though we have them here. So what they are going to do is what they are going to dispatch. They are going to dispatch the error message. Meaning of dispatch is that if you have an error message in a library, whatever contract of a set, in this case, whatever contract of a set implements or uses the library needs to implement that particular error message. So when the library dispatches the error message, the contract also must have that error message so that it can implement the error message. Do we get? Now, another thing that we need to know is that yes, all these structs that we have here, all these structs, they are just skeletal structure of how, a variable can be. They are just skeletal structure of how a state variable can be. So which means that all these facet address position, all these ones, they are not what state variable. They are not state variables. So this one now. So we we are now we are not thinking about when we now look at our we said that our facets they handle functions. Now in the diamond itself, that's where the storage is kept. So how do we decouple our facets from handling storage? Facets, what we want them to do is just to run functions. After that, nothing else. Meanwhile, it should just be our diamond contract. It should just be the normal diamond or so. That one should just be. What it's majorly doing is just taking function selectors, mapping it to a facet and delegating it to the facet to execute. So that's what we want our diamond to do. So in order for us to be able to do that, there are now some concepts that we can make use of. So we know that the diamond also, it makes the facet to execute a particular function using what is called the delegate call. What is a delegate call? In a delegate call, you have a particular contract. It is asking another contract to execute a particular function in its own context. You have a contract A, it is delegating a function to contract B in its own context. That is, contract B is standing in for A, and whatever contract B does, it does it in the storage of A. whatever contract B does, it's doing it in the storage of A. So that's simply what it's all about. And before you can have a proper delegate call, it means that the storage layout of both for the storage layout of the context of what is required to perform a particular function. So the storage layout of contract A and contract B must be the same. So in order to now ensure that the storage layout of our diamond is consistent across, in order to ensure that the storage layout of our diamond is consistent across all facets, that's when we now have, yeah, okay. So what is meant by storage layout is the structure, is the structure. That is, let's say that I want to make, if I'm making a delegate call from contract A to contract B, and contract A, it has a state variable. It has a state variable, let's say owner. It has another state variable, let's say car, another state variable boss. So it has owner, boss, um, owner, car, boss, like that. So what it is delegating it to must also have that owner, car, boss in that, in that layout, in that order. So the two of them must have the same storage layout. That's what is meant by storage layout. So which means that when you are thinking about storage layout in our library, the default thing that we know is that libraries, they don't store storage. Libraries don't have storage. That's the default thing that we know. Or that's the rule number one that we started from. Libraries don't have storage. Then we proceeded to say that what they can have immutable constant. They can have immutable constant. If you should have a storage in the library, it means that it can change state. But the default thing that we know is that what libraries don't change state. So let us now proceed. So either it is what is it called, diamond storage or app storage. The two of them, they are ensuring structure. Now, how are they now ensuring structure? Or what is the principle behind the two of them? In fact, the two of them, they are almost the same thing, but there's just a small difference between the two. Now, for either you are using a library, either you are using what's it called, a diamond storage or an app storage, either you are using any of the two. What you want to do is that you want to have a struct. If you should look at this lib diamond now, this place. Now let's look at this thing very well. We have in line 26, we have struct, facet, address, and position. Mhm. We have some, they are just structure. Then we now have another structure, which is what diamond storage. Now this, we now have a layout. In the diamond storage, the first variable that we have is selector to facet and position. Now you see that this facet, address, and position, we are not using it anywhere else except that we are saying that this one is mapping to this. That's what we are doing here. Now in this place too, this one too, we are just saying that this one, we are mapping address to facet function selector, which means that these two, when you are considering your diamond storage, these two are just struct. These two are just struct. So even though our diamond storage 2 is also just struct, but then we are making use of these two inside it. So in our diamond storage, we have the layout. So this in layout, let's say that, so which means that if in diamond storage, we can set the storage location or the slot position of this our diamond storage. If you should give it a particular slot position, are you hearing me? If you should give this a particular slot position, then this one is going to take that position plus one. Then this one is going to take the position plus two. This is going to take the position plus three. And this is going to take the position plus four. Is that understood? So this is taking the position plus one. This so let's assume that the slot position of this one is at slot 11. This one would be slot 12. This one would be slot 13, and this one would be slot 14. So that's the simple logic behind it. Now, when you now say that a diamond storage and an app storage, the difference between the two is just where the slot position is just the slot position. For app storage, whenever you are using the app storage, the slot position is starting at 0. For app storage, the slot position is starting at where? 0. But for diamond storage, you can set the slot position that you want it to be. You can give it any slot position that you want. So that is why, because this one is diamond storage, we are now using here. We are giving it an ID. This is the ID. The ID can be anything. It can be anything that you like. So here we are just using this string, diamond or standard or diamond or storage. You can add or remove anything that you like. This is just an ID. Then we hash it to get what? Byte 32. So we are now setting this as our what? Diamond storage position. So this is going to be our diamond storage position. And of course, our library can hold that constant. So now, all this one that we are talking about now, it will still a structure. So the real diamond storage, this is it in line 51. So in line 51, we are now saying that what we now have a function. We say function diamond storage. It is internal, pure. If it's returning this, it's returning this diamond storage, this struct that we have here. It is returning as storage. Now you know that we have 3 data locations: storage, memory, and core data. Storage is what modifies state, which means that when we use this storage, whenever we are editing it, or whenever we are changing it, the change will be persistent. But assuming we are returning memory here, and we can return memory, if we should return memory here, it is going to be read only, which means we can only read it, we cannot what? Change it. Do we get? So we are returning in it as DS. So in this place now, we already know that, of course, byte 32 position, we are setting position as what? Diamond storage position. This diamond storage position was, the constant that we declared here, diamond storage position. So DS that we are returning to be equal to this position that we have here. So this one is the diamond storage. Now, this is the diamond storage. Let me now talk about app storage. For app storage, when you already have, let's say, a struct, you can have a struct anywhere. This struct, maybe you have it, the layout that you want to make use of, you can have it anywhere. Then in your facet, which is the contract. Now we need to understand the difference. When I talk about facet, you know that facets are what? Contracts. Libraries are different from facets, right? You cannot declare a state variable inside a library. You cannot declare a state variable inside a library. You can declare a state variable inside a facet. So when you declare an app storage inside your facet, let's say that you declare an app storage inside your facet. Let me show you something. So let's say that I'm going to create example dot so. I'm going to delete it afterwards. Let me just copy this. So in this place now, I can say that what I have a struct, and call it app storage. Then in this place, I'm going to have the layout of my listing. So let's say this variable one. So in this place, I can even have, you know, mapping of, let's say, string to that hello that we declared up there, and call it something. How far now? Oh, okay, okay. Yeah, it's still live, still working. Thank you for that. So now we have this. Then inside this contract here, let's now say that we now have here. We can declare it as what? As a state variable here. We say that app storage internal, and call it what? Let's call it AS. So identifier public internal. Oh, okay. This one will be. um, Sorry, some minutes. Oh, okay. So the reason it was showing the error was because of the name. I think this AS is. So uh let's just call it S. Now, so in this place now, what this one is going to do, because this is the first state variable. For if you are using app storage, you need to make sure that it is the first state variable. So because it is the first state variable, that we declared, the slot position is going to be what? Slot 0. The slot position is at slot 0 because it is the first state variable. So we need to take note of that. Now, we cannot use this app storage. We can only use it inside where we can say that this one is a what is a contract, or we call it what a facet. That's when we can make use of, we can initialize an app storage this way. So if you now think of it, how can we, let us now say that we want to, like we used an app storage in the variable in the facet, and we now want to like replicate something like that in a library. We want to replicate something like that into what? To 0. It is the same thing when we are using assembly. So this one, what we have done here, like this state variable, is the same thing as setting it to what? Setting the state variable to 0. So that is the difference between diamond storage and app storage. If you have any question on that one now, before we proceed, you can ask now. If you have any question on that, you've you've missed the two. Diamond storage is the one that uses ID. It's the one that you can set any slot position that you like. App storage is the one that starts from slot 0. You're welcome. So is there any other question? Okay. Library don't change state. Okay. So talking about changing of state by library, we know that libraries they don't have state variables. Hmm? Libraries don't have state variables, which means that they cannot change their own state. Like they don't even have a state variable. So the default thing is that they don't change states. That's where we are library. If a library is implementing an internal function, we can if we pass reference. The reason libraries don't change state is because they don't have state variable. But if we should pass a reference to a state variable to library, they are going to what change that state. So it's just similar to what to delegate call. So we know that in delegate call, you are going to the contract that you are making delegate call to is going to change your own state. So that's how we are going to be thinking about library also. So libraries they don't change state, but if you pass reference to a state from where you are calling it from, they can change it. Now they also don't what they also don't emit events, but they can dispatch error message or error events. So which means that whatever event you want them to emit or to dispatch, whatever contract is implementing or calling that contract must have the what's it called, the library. Okay, so the belief now is that if we are woken up from sleep 4 a.m. in the morning, what's the difference between app storage and diamond storage? So we should be able to do that very easily. So now we are going to proceed now. So now what I'm going to do now is, yes, I already have what's it called? I have cloned it here, so I will need to do yarn install or npm install. So the next thing, another thing is that if you should look, if you should really look at this thing, so the package files that we have there, there are some things that will be, already they would have, how do I call it? I don't want to say duplicated, but they are kind of old. Okay, yes. What's the error? From, I don't get it. Can you share your screen? Yes. Looks like someone else is talking. Does the person have solution to that? Oh, you can use npm install. So in order for my what's it called? My Foundry also to install. So I'm going to forge updates to install my Foundry. Sorry. Looks like you've stopped presenting. Okay. Offer. No, I can't. I can't see your screen now. I think you should try npm install. So if you have this thing with that, then you can know. So now I have done Forge update. So I want to check my, where is this leave? Okay. So I have this one, this there. So I want to check something in this test. This test vm.so. Yeah, that's nice. Let's continue. Okay. So now, hello, can you hear me? Can everyone hear me? So now, this one, it has the configuration and everything that we currently have here. So it should still like, it should work perfectly. Now I'm just going to do Forge Forge C for the to run the test, like the default test that is there. So let me put it on watch. So you can see that currently it's saying that the location, what's this? So then let me do the Forge again. So it's still doing the same ds test slash test dot so ds. What is this one? Import. Wait, where is this one? src slash test. Where is this src? So what this one? Let me just find it again. Let me run Forge install again. Okay. So I want to check something. So because I realized that there is one command that I was trying. It should be in VM. No, still not there. Okay then. So now this one is currently compiling. So this is just our, like this is the base, what's it called? This is the base contract, the test, which means that the diamond contract itself is working. So which means that if we should, moving forward now, if anything happens to it, it means that the error is coming from us. So currently, now, if you have problem after Forge update, so you should do Forge install again so that it's going to we install whatever package is currently not there. So can we proceed now? So that I'm going to try to be explaining the process, like the reason why we are doing some of the things that we are going to be doing. So should we start now? It's like nobody is online again. Like we want to convert this blind NFT auction. We are going to be converting it to standard. Okay. So basically, in this blind NFT auction, I'm going to try to like explain what is happening here. So so I have the this is the contract blind NFT auction. So what is done here is that no, it's not NFT auction that I want to do. Sorry, that was a mistake. It is buy with token that I want to do. Buy with token. This one will be okay, yes, this one. So in this buy with token, so what it's basically doing is that you can list. So it's like a marketplace. We have a marketplace where you can come to list any of your assets. If you have any assets, basically we are thinking of asset as an NFT, that is an ERC 721 token. So you can come and list your assets, and anyone that wants to buy it with can basically buy it with any token. Do you get? So if you come to the platform, you can say that I want to sell this ERC 721 asset. I want to sell it for 10 ETH. So when the person comes, so the person might say that, okay, I want to buy it for USDT. I want to buy it using USDT, or I want to buy it using DAI, or I want to buy it using any token that they like. So what we are going to do, what's happening internally here is that whatever token that you have used to list it, we are going to use the chain link to find the exchange rate of that token that you've used to list it with whatever token that the person is using, the person wants to buy it with. So then after that, the person is going to transfer the money to you, then we are going to transfer the assets to the person. So basically, the contract is written. This is the contract here. It has interfaces, and we also have the test. Like I've already written a test for it before, and I've already written a test for it before. So we are going to be looking at how we are going to convert this to diamond, and also we are also going to do the same test. We are also going to do the test. Um, we are going to do the same test for it. So let us now start with the contract. This is the buy with token contract. Hmm? Very simple. This is everything in the contract. Now, there are some things that we need to look at here. So the number one is that in this contract now, we have this aggregator interface. Mm, So we have this aggregator interface, reasonable, everything. So the first thing that we want to look at is our the storage. Let us first undo the storage. We want to first undo the storage. Now, for this contract, all the storage that we have, all the storage that we have is just this. This is the pattern of all the storage. We have item ID, aggregator, token details, listed NFT. So these four are the only storage that we have. So this one is a struct, this is a struct. So what we are going to do is that we are going to copy this storage. We are starting by copying this storage. Hmm? Then in our library, so we are going to, in our libraries, where is the libraries? Paper. Okay, inside the contracts, then we have libraries. So in this place, we are going to create lib. We want to use app storage dot so. Hmm? So in this lib app storage dot so, because let me just paste this there. I'm going to copy that, what's it called? The identifier. So I like to specify the exact compiler version I want to use. Dot 18. Then let me remove this. What's happening? Okay, let's use 19. So I have token market. So this is the one that I want to, this is where I have my, so in this place now, I'm now going to create another struct and call it what? App storage. So in this place, that's where I'm now going to have my storage layout. So this is my storage layout. Now in this place, I'm not going to define, maybe it is private or public. It's the app storage system that I want to make use of. It's the app storage I want to make use of. So now, exactly, exactly. So in this place now, I'm now going to create library and call it lib. So inside this place, so I'm going to write a function and call it what? Get app storage. So the function is going to be um, pure. It's going to be internal pure returning. It's going to return app storage. So let's call it what? S. So in this place now, we are now going to write assembly. Then we say that what? S dot slot. We have here this get app storage that we have here. So you can have it in any other place. You can have it in any other place. But we are just having it here. Normally for normal app storage, we don't even need to be declaring s dot slot to be equal to 0 in this place. You can just go to, when you are using it in a facet or a contract, facet and contract, they are the same thing. When you are using it in a facet or contract, just declare it as internal and make sure that it's the first variable. It's going to automatically take the slot position of 0, the 0 slot position. Do you get? But yes, yes. So inside a facet, by facet I mean a contract. Inside a contract, yes. So this app story, the way it is there, exactly. So assuming we want to use it in a facet, this one is library. Okay, let me, in this place now, let's say I'm going to what? If I write a contract and I say what? Contract use app storage. Hmm? So in this contract, if I want to use this app storage, what I'm going to do is what? I will just write app storage internal s. That's all. Now look at this two. Now look at this, these two now. They are the ways of declaring app storage. Now this one is used for library. This one is used for what? For contracts. So this structure is just giving it a structure. Do you get? So this one is used for library, lib app storage. This one is used for what? Contract. When you are declaring it inside a library, you know that you cannot declare a state variable inside library. So you need to make use of an assembly to set the slot position. When you are declaring it inside the contract, the contract, hmm, when you make it the first state variable, then it means that it will automatically be set to 0. The slot position will automatically be set to 0. Yes, this place. Look. Hmm. So if you want to use app storage in a contract, you are going to just app storage internal S. That S is setting the slot position towards 0. So this one is lib app storage. So this one is a library. In a library, you cannot set a state variable. So we are now using assembly. Okay. Azal. This look look at line 1 and line 2. We have it already now. Line 1 and line 2. You're welcome. So so we now know how to use a what's it called? An app storage, right? What? Okay, you can ask. Okay. Yeah. Yes. They are not taking any position. They are just structure. When you have a struct, you still need either an array or a map to instantiate its storage. And this pattern is no longer a problem, right? So each of them, they have their limitations. We can go through um, the EIP, the articles, uh, this article by Mudge to look at the limitations. So you can go through the article to look at limitations. You can have there are like more patterns that you can actually explore. Maybe you want to have a storage that will be used by some facets and all of those stuff like that. So there are patterns that can be explored. But the main cocoa is just that number one, you want to avoid collision of storage layouts. Number one. And number two is, you have to be consistent because immediately one data is corrupted, then that's the end of it. You've destroyed the contract with that. So now that everyone now understands how to use both diamond and app storage, we can now we can now proceed. So this is our what's it called? Diamond storage pattern. So the next thing that I want to now do is that normally in this facet, right, we can create what's it called? In the facet, we can have all our functions. We can create them inside the facet and do everything there. But then I still want us to do something else. So instead of really having our functions inside the facet, I want us to have all the functions to be like function helpers. So we are going to have the functions inside the library, you know, and the facet will now be using that library internally so that our facet will be good looking. What do I mean? So in this case now, so we have all these now we have list asset, buy asset with token, add token details, delete token details, and all this. So let me copy this two first. So here I'm going to create another library, lib, what's it called? Buy token. Uh, I still need all this pragma. Then I will have, so this is going to be a library, lib, buy token. So, so I have this function. I'm going to, so let me just choose these three. I'm going to have, so to make use of some storage in this case. So what we are going to do is that we are going to import from